Hello class, welcome to our lesson today. We're going to be looking at section 8.3. This deals with testing claims about proportions. Now we've already talked a little bit about hypothesis testing and how to set it up and what it looks like. So we're going to continue that idea today and then test claims about the proportion. First thing to make sure of is some notation issues that we want to make sure are taken care of. First off, n is still the number of trials. P is the proportion of the population or whatever the claim is. And then p hat is the sample proportion, which typically you have to find by taking x over n. The requirements are similar to what you've seen before. There has to be a simple random sample, there has to be a fixed number of trials, and basically it has to be a binomial case, which means there's only success and failure as you move forward. One other thing to check to make sure that it works is that n times p has to be greater than or equal to 5, and n times q has to be greater than or equal to 5. If you need the mean and standard deviation for any of these questions, the mean is found by taking n times p, and the standard deviation is n times p times q square rooted. Those ideas revert back to binomial distributions and what we looked at in Chapter 5 and Chapter 6, but you want to make sure that you're looking at some of those ideas as we move forward. Some of your homework last week and this week will include finding the test statistic. The test statistic is what z-score corresponds to whatever information we have. So you have to find p hat, which is the proportion of the sample, minus p, which is the population proportion or whatever the claim is looking at, divided by the square root of pq over n. You find all of that, you round to 2 decimal places because we're still using the z-score table. You won't have to worry about the t-distribution table on these questions because everything is proportions and binomial cases, which means it correlates directly to a z-score table. We're going to go through a few examples in their entirety. There's a lot of information here and a lot of wording that we have to look at, but this covers everything that you have to go through in order to have a successful answer on a lot of these questions. So this says among 726 pea pods, that's n, we're trying to genetically modify more yellow pods, and 665 of my 726 were yellow and the rest were green. Use these results with a 5% or 0.05 significance level to test the claim. All right, now here's what we want to deal with first. The claim is that among the pea pods grown in the method, the proportion of yellow pods is greater than 0.5. So my null hypothesis, because I care about 0.5, is the proportion equals 0.5. The null is always equal to. The alternative then is the proportion is greater than 0.5 because I'm trying to test that claim. My alpha level is 0.05 because it's a 0.05 significance level. From there, I find the test statistic. So z equals, I say that I got 665 out of 726. That's my p hat number from the given information in the first sentence. Minus the claim, which is 0.5, divided by the claim p and q, 0.5 and 0.5, divided by n, which is 726. You should not always assume that it's 0.5 for p. A lot of proportion questions are 0.5 to start with, but it won't always be the case. I plug all that in, I should get a z-score of 22.42. Now that alone, without even finding anything with critical values or anything like that, that alone probably is like, okay, that's unusual. Okay, that's probably going to be an unusual situation. But let's go through how we find the p-value. Since the alternative is a greater than, that means my test over here is a one-sided to the right test. Because of that, my p-value is going to be 0.0001 by taking 1 minus the area to the left. And so this area underneath the curve is 0.0001. This is clearly less than the significance level of 0.05. That's one way you could determine whether to fail to reject or reject the null hypothesis. The other option that your book typically will use is what's known as the critical value. You could find the critical value, which is basically saying find the area to the right that is 0.05. That area to the right should be 1.645. Notice here 1.645 would be further over towards the center. So this would be the critical value. Anything past 1.645 would be considered unusual, which correlates to the exact same response. Either way, we're going to reject the null hypothesis. Now we have to explain ourselves when we reject or fail to reject. We reject the null hypothesis, which then says there's significant evidence to support the claim that the alternative, which is the proportion of yellow pods is greater than 0.5. Okay, there's all of these steps involved in order to answer this question, and all are necessary because they all correlate together to come up with the conclusion that's written here in the bottom right. So you write your null and alternative, write the significance level, alpha, find the test statistic, find the p-value or the critical value, and then reject or fail to reject the null hypothesis, and then a statement about what that means. The next question says that you're trying to determine if people randomly guess correctly the coin toss of the Super Bowl. So ideally, the coin toss is 50-50, 50% heads, 50% tails. There's an important aspect of this question that we need to talk about. It says among the 104 people selected, 55% correctly guessed the coin toss. The question is, well, really, how many people did guess the coin toss? Because p hat seems to be 0.55 or 55%. But you may end up with an answer that's slightly off. So here's what we want to look at. 104 people were asked, and 55% guessed correctly, which correlates to 57.2 people. What that probably means is there were 57 people that correctly guessed, which means my p-hat number is not 0.55. It's a little bit different because it should have been 57 out of 104, and that'll make it slightly different than 55%. It obviously was rounded for the sake of rounding. But we might want to use 57 out of 104 as p-hat instead of just 0.55. Okay, same information. Use the sample data to test the claim the success rate of guesses is not different than 50%, which is just by random guess then. Use a 5% significance level or 0.05. Null hypothesis, probability or proportion is 0.5. Alternative, all I care about is if it equals 0.5 or not, so it's not equal to 0.5. The significance levels alpha equals 0.05. My p-hat number, which I just talked about on the previous slide, would be 57 over 104 minus the 0.5, then divide by p times q, and then divided by n. I get a z-score value this time of 0.98. Because the alternative hypothesis is a not equal to, my testing areas are actually two-sided because it's a not equal to question as opposed to the first one, which was just a greater than question. So for this scenario, it is true that my z-score is 0.98, but there's a second z-score that's negative 0.98. These are the two sides that I deal with. To be honest, the easiest way to find this answer is to do the negative one because that does area to the left. If I look up negative 0.98 and find the p-value inside the table, I get 0.1635. I just double it because these two areas are symmetric, and so I just double that, and that'll be about 0.327. That number is way higher than the significance level, which means this is just by chance. In order for it to be considered unusual, it has to be less than that significant level of 0.05, and so in this case, we failed to reject. The other option for this case is you could use the critical values. Since it's two-sided are same as confidence levels. So 0.05 would correlate to 95% confidence, which is 1.96. 1.96 would be further down towards the end versus my number of 0.98, which also shows that I failed to reject. Now, when you fail to reject, there's two ways you can kind of say this. I tend to just use the same wording and just put the word not. So, failed to reject the null, there's not sufficient evidence to support the claim that the true proportion of correctly guessing the coin toss is different than 0.5. There's also some wording in your book that says like there's no way to warrant rejection of the initial information or the null hypothesis. Either way is okay. I tend to look using the same information multiple times, so I tend to go with the route of failing to reject the null and then not sufficient evidence to support the alternative. Either option is fine. In testing situations, you're going to have to go through this whole process. It will take some time. You need to make sure you're using your z-score table to find these answers. When we get to some of the other sections in Chapter 8, you may have some technology pieces that you'll use, but in general, we're just going to use the z-score idea in order to find those situations. Make sure you know how to find the null, alternative hypothesis, test statistic, p-value and or critical value, and then write your conclusion. Those are all the things you need to know for Section 8.3. Have a good day, everyone.